And now in this lecture, I'm going to answer two questions. In the first question, we find out the length of this line segment AQ that equals to x. We have to find out the value of x. And in the second question, we'll find out the area of this quarter circle A or B. So we'll start with the first question. In the drawing, we have a semicircle APCB. We know that this is the line segment QC. And this equals to 6 units in its length. And this is called CB. This equals to 5 units in its length. This is again PQC. This is the right angle. And our task is to find out the length of this line segment AQ that equals to x. We have to find out the value of x. In addition, we know that arc AP, this is arc AP, is equals to arc CB in its length. And then our test is to find out the length of this line segment AQ that equals to x. We have to find out the value of x. So first of all, we can implement rule 7 in our drawing. So please click on rule 7. According to rule 7, if a peripheral angle subtends on the diameter of the circle, then it equals to 90 degrees in its size. So in the drawing, we have a circle. This is peripheral angle ACB that subtends on chord AB, that is the diameter of the circle, and therefore peripheral angle ACB must be equal to 90 degrees in its size. So according to this rule 7, any peripheral angle that subtends on the diameter of the circle must be equal to 90 degrees in its size. So we can actually implement rule 7 in our drawing. One point in our drawing, we have this is peripheral angle ACB that subtends on chord AB, the diameter of the semicircle, and therefore according to rule 7, peripheral angle ACB must be equal to 90 degrees in its size. AB is the diameter of the semicircle, so find the norm. Chord AB is the diameter of this semicircle. According to what is given as the question, this is arc AP that equals to arc BC in its length. So here we can implement rule 56. First of all, according to what is given as the question, arc AP is equal to arc CB in its length. The rounded sign above CB and AP is the sign for arc. It means that arc AP equals to arc CB in its length. And here we can implement rule 56 in our drawing. Whenever you have two arcs that are equal to each other in their lengths, you can implement rule 56. So I click on rule 56. According to rule 56, if two arcs are equal to each other in their lengths, then their corresponding chords must be also equal to each other in their lengths. So in the drawing, we have a circle. This is arc AB. This is equal to arc CD in its length. And because of the fact that those two arcs are equal to each other in their lengths, then their corresponding angles and their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc is called AB. The corresponding chord of this arc is CD. So those two corresponding angles must be also equal to each other in their lengths. That is to say, chord AB equals to chord CD in its length. So we can implement rule 56 in our drawing. It's given us the question that arc PA equals to arc CB in its length, and we join points A and P together by a straight line. Arc chord AP is the the corresponding code of this RKP. Repeat again, code AP is the corresponding code of RKP. Likewise, this is code CB, this is the corresponding code of RCB. According to Rule 56, because of the fact that those two arcs are equal to each other in their length, then their corresponding codes must be also equal to each other in their length. That is to say, code CB equals to code BA in its length. So code CB is equal to code AP in its length according to Rule 56. But it is given us the question that this is code CB, this is equals to 5 units in its length. So we can write here that code AP equals to 5 units in its length. And so this equation 5 equals to AP equals to CB, we will derive that code CB equals to 5 units in its length. The code CB equals to 5 units in its length. And from this equation AP equals 5 equals to CB equals to AP, we will derive that code AP must be also equal to 5 units in its length. Okay, this is called AP, this is equals to 5 units in its length. Moving to Rule 56. In the next step, we will join points P and C together by straight line. By joining points P and C, we consider two peripheral angles. This is peripheral PCA. Again, this is peripheral PCA that subset on code P8 is equal to 5 units in its length. Likewise, this is the other peripheral angle. This is peripheral angle BAC. Again, this is peripheral angle BAC, the subset or code CB that is also equals to 5 units in its length. And because of the fact that those two peripheral angles subtend on equal codes, is equals to 5, they must be equal to each other in their sizes according to Rule 57. Please click here on Rule 57. According to Rule 57, if two peripheral angles subtend on equal chords, then they are equal to each other in their sizes. In the drawing, we have a circle. This is peripheral EDF that is subtend on chord EF. Likewise, this is peripheral ACB that is subtend on chord AB. And because of the fact that chord EF equals to chord AB in its length, those two peripheral angles must be also equal to each other in their sizes. That is to say, peripheral EDF is equal to peripheral LBAC in its size, or alpha equals to beta. So we can implement Rule 57 in our drawing. One code in our drawing. Those two peripheral angles subtend on equal chords. This is equals to 5 units. And therefore they must be equal to each other and their sizes. So write it down. This is peripheral PCA. This is equals to this peripheral CAB. According to Rule 57. So if we define the size of this peripheral PCA as alpha, then the size of this peripheral CAB must be also equal to alpha because they are equal to each other in their sizes according to Rule 57. The next step, we will focus on this right triangle PQC. Now we focus on this right triangle PQC. This right triangle PQC. This angle equals to alpha. This angle equals to 90 degrees, and therefore this plus this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, this lower right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this plus this angle must be equal to 90 degrees minus alpha. According to the sum, that says that the sum of the angles in any triangle is equal to 180 degrees. So this plus this angle must be equal to 90 degrees minus alpha. It is very easy to see that this is again right triangle PQC is similar to this right lower triangle ABC according to angle similarity rule. That is to say, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So if we found out that all the angles of this green right triangle PQC are corresponding equal to all the angles of this right lower triangle ABC. Therefore, those two right angles are similar to each other according to angle similarity rule. So right now, if we found out that the right green triangle PQC is similar, this is the sign of similar to this right lower triangle ABC. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC or side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC or side AC of this right lower triangle ABC. So write it down. PQ or CB equals to QC over AC. So if it again from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of the green right triangle PQC or side CB of the right triangle ABC is equal to side QC of the green right triangle PQC or side AC of the right triangle ABC. PQ is the missing side, so we leave it as it is. Over CB, CB equals to 5. And it is equals to QC, QC equals to 6 according to what is given as a question. Over AC, AC in total equals to x plus 6. So in total, we should find out that PQ over 5 equals to 6 over x plus 6. Here we will multiply this equation by 5 and finally get that the missing side PQ is equal to 6 times 5 is 30, so this expression in total equals to 30 over x plus 6 units in its length. and the missing side PQ equals to 30 over x plus 6 units in its length. Repeat again, this is the missing side PQ. This is equals to 30 over x plus 6 units in its length. It's given us the question that AC is a straight line. So if you focus on the upper side of the straight line AC at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle that is the right angle, plus this missing angle. In total, the sum of those angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the next step, we will implement the Pythagoras theorem on this right small triangle, triangle APQ. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle APQ, here by PT is the abbreviation for Pythagoras theorem. So in this right APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ square plus QA square. And again, in this right triangle PQA, according to the Pythagoras theorem, AP square, that is the square of the hypotenuse, equals to PQ square plus QA square. AP is 5, therefore AP square is 5 square, that is 25. And it is equals to PQ square. PQ is 30 over x plus 6. And therefore PQ square must be equal to 30 over x plus 6 square plus QA square. QA is x, therefore QA square is x square. X is the variable that you are looking for in this question. So in total, we should find out that actually x is not a variable, but x is the length of line with AQ. We are looking for the length of AQ is equal to x. We have to find out the value of x. So in total, we should find out that 25 equals to 30 over x plus 6 square plus x square. So 25 equals to 30 over x plus 6 square equals to 30 squared, that is 900 over x plus 6 square. So this expression in total equals to 900 over x plus 6 square plus x square. So if we found out that 25 equals to 900 over x plus 6 square plus x square. Here we will multiply x square by x plus 6 square, and then we will divide it by x plus 6 square in order to have a common factor with this number. So we have x square times x plus 6 square, and then we divide it by x plus 6 square, so we change nothing. It is allowable to multiply any expression by 1. So in total, we should find out that 25 equals to 900 plus x square plus x plus 6 square. So here we multiply this equation by x plus 6 square, And finally we get that in this side of the equation we have 25 plus times x plus 6 squared. On the other side of the equation we have 900 plus x squared times x plus 6 squared. So in this side of the equation we have 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is plus 12x, and it is equals to 900 plus x squared times x plus x squared. X plus x squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. So here we'll open the brackets on both sides of this equation and finally get that 25 times x squared equals to 25x squared. And we have here 25 plus 36 is 900. And we have 25 times 12x is 300x. And it is equals to 900 plus this expression. So we'll open the brackets of this expression and we'll get that x squared times x squared is x to the power of 4 plus 36 times x squared is 36x squared, and we have x squared times 12x equals to 12x cubed. So here we have 900 on both sides of this equation, so 900 will get cancelled. After we cancel 900, in this side of the equation we left only with 25x squared plus 300x equals to x to the power of 4 plus 12x cubed plus 36x squared. Here we subtract 25x squared from this equation, so here what is left after we subtract 25x squared in this other equation, what is left is actually 300x equals to x to the power of 4 plus 12x cubed, and we have 36x squared minus 25x squared is equal to 11x squared. So here we subtract 300x from this equation. So in this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we have x to the power of 4 plus 12x cubed plus 11x squared plus 300x is equal to 0. So I'll copy this equation in a new page. So I should find out that x to the power of 4 plus 12x cubed plus 11x squared plus 300x equals to 0. So again, if you find out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we take out x as a common factor from those two four expressions. So inside the brackets we left only with x cubed, and we have here plus 12x plus 11x minus 300 equals to 0. Actually, this equation has two solutions that are possible. The first solution for this equation is that x equals to 0. If x equals to 0, then 0 times anything is 0, and get that 0 equals to 0. So x equals to 0 is the first solution to this equation. The second solution for this equation is that expression inside the brackets equals to 0, so 0 times x is 0, and get that 0 equals to 0. So the second solution to this equation is x cubed plus 12x plus 12x squared. We took x second factor on this expression, so we left only with 12x squared plus 11x plus 300 equals to 0. This 12x squared plus 11x minus 300 equals to 0. So the first solution for this equation is x equals to 0. But actually x can never be equal to 0 because why? Because x is the length of line element AQ. So x is a length must be a positive number. So x can never be equal to 0. Why? Because of the fact that x is the length of line element AQ. So x is a length, it must be a positive number. 0 is definitely not a positive number, and therefore this solution is the correct solution. So we cancel the solution, and we left only with the second solution that is possible for x, that is to say x cubed plus, actually it is the second solution to this equation, that is to say x cubed plus 12x squared plus 11x minus 300 equals to 0. So first of all, we check that if x equals to 3 solves this equation. If x equals to 3, then we just have to substitute x by 3 in this equation and get that x cubed equals to 3 cubed. 3 cubed is 3 times 3 times 3, that is 27. Plus 12x squared. X is 3, so x squared is 3 squared, it is 9. 9 times 12 is 108. Plus 11x. X is 3, so 11x is 11 times 3, that is 33. And we have here minus 300. Is it equals to 0 or not? Actually, we have 27 plus 33 plus 100, in total it is 168, so 168 minus 300 is definitely not equal to 0. So x equals to 3 doesn't solve this equation. So x cannot be equal to 3, but the left side of the equation is not equal to the right side of the equation. The next step, we check if x equals to 4 solves this equation. If the solution of this equation is x equals to 4. So if x equals to 4, then we just have to substitute x by 4 in this equation. So if x equals to 4, it means that x cubed is 4 cubed. 4 cubed is 4 times 4 times 4, that is 64, plus 12x squared. X is 2, so x is 4, so x squared is 4 squared, that is 16. times 12, 16 times 12 is 192 plus 11x. X is 4, so 11x is 11 times 4, that is 44. Minus 300, it should be equal to 0. 64 plus 44 is 108. 108 plus 192 is 300, and 300 minus 300 equals to 0. So x equals to 4 is the solution of this equation. And therefore, we can present this expression in a different way. Actually, x cubed plus 12x squared plus 11x minus 300 is identical to the following equation. This is x minus 4 times x squared plus 16x plus 75. Actually, if you just open the brackets of this expression, you find out that this expression in total equals to this expression. You can try it and open the brackets of this equation, and you find out that those two expressions are identical. So you can substitute this expression, this equation, by this expression, because they are equal to each other. So we do it now, we get it x minus 4 times x squared plus 16x plus 75. So we know that x cubed plus 20x squared plus 11x minus 300 equals to 0. But those two expressions are identical, and therefore this expression must be also equal to 0. We just substitute this expression by x minus 4 times x squared plus 16x plus 75, and it equals to 0. This expression equals to 0. Now it is very easy to solve this equation. Here we have two solutions that are possible for this equation. The first solution to this equation is x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. You get that 0 equals to 0. The left side of the equation is equal to the right side of the equation. So x equals to 4, x minus 4 equals to 0 is the first solution to this equation. So if x minus 4 equals to 0, we add 4 to this equation, and we get that x equals to 4. So the first solution to the question is that 978 cubed equals to x is equals to 4 units in its length. But we have another solution to this equation. If this expression equals to 0, then 0 times x minus 4 equals to 0. The left side of the equation is equal to the right side of the equation. So the second solution to this equation is that the expression equals to 0. This expression equals to 0 inside the brackets. So x squared plus 16x plus 75 must be equal to 0. But we must verify that this equation, this quadratic equation is true. In order to verify that this quadratic equation is true, we know that the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Actually, this is a quadratic equation, or any quadratic equation has a solution only and only if the expression inside the root is a positive expression. That is to say, we don't have a root to a negative number. Therefore, the expression inside the root must be a positive number. the expression inside the root is defined as determinant. So determinant b squared minus 4 times a times c must not be a negative number, because we don't have a root to a negative number. So b squared minus 4 times a times c must not be a negative number. So check what is the value of the determinant of this our quadratic equation. In our quadratic equation, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. Again, in our specific quadratic equation, that is to say x squared plus 16x plus 75 equals to 0, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. So we check out what is the value of the determinant of this expression. The determinant of this expression equals to b squared minus 4 times a times c. b is 16, therefore b squared is 16 squared. This is actually 256 minus 4 times a times c. A is 1, so minus 4 times a is minus 4 times 1, that is 1, minus 4 times c. Minus 4 times c is minus 4 times 75, that is minus 300. 256 minus 300 is definitely a negative number. So that is why we found out that the determinant of this quadratic equation is a negative, and therefore this quadratic equation has no solution at all. And because of the fact that this quadratic equation has no solution at all, we cancel this possibility. That is to say, x squared plus 16x plus 75 equals to 0 is the correct equation. Actually, you don't have any x that is a real number that can solve this equation. Therefore, the solution is the correct solution. Okay. So left only with the other solution that is solve this equation, that x minus 4 equals to 0 and then x equals to 4. So the answer to this question is that line 17 cubed is equals to x is equals to 4 units in its length. So finish the answer of the first question. In the next step, I present you the second question and we'll solve the second question of this lecture. In this second question, our task is to find out the area of this quadrilateral, area of this quarter circle A or B. So, in the drawing, we have quarter circle A or B. This is the short line side PQ is equals to 4 units in its length. This is the short line side AQ is equals to 4 units in its length. This is again PQ8, that is the right angle. Again, our task is to find out the area of this quarter circle A or B. So first of all, OA equals to OB, they're both the radii of this quarter circle and therefore they are equal to each other. So we define the radius of this quarter circle as R. So OA is the radius of this quarter circle equal to R according to our definition. Likewise, OB is also the radius of this quarter circle. Is equals to R. So we have the rule that says that in front of equal sides in the triangle there are equal angles. if we focus on this right triangle AOB, in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes, according to the rule that I mentioned. So if we define the size of this angle as x, then the size of this angle must be also equal to x because they are equal to each other, according to the rule that I mentioned. We also note that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle AOB must be equal to 180 degrees. That is to say x plus x, that is 2x, plus 90 degrees, in total must be equal to, the sum of those angles must be equal to 180 degrees. So right now, this right triangle AOB x plus 90 degrees, in total the sum of those triangles must be equal to 180 degrees. Repeat again, in the right triangle AOB, the sum of the angles must be equal to 180 degrees. That is to say, 2x plus 90 degrees in total must be equal to 180 degrees. Here we will subtract 90 degrees from this equation, and when we get that 2x equals to 180 degrees minus 90 degrees is 90 degrees. So 2x equals to 90 degrees. Here we will divide this equation by 2, and when we get that, let me say again, x equals to 90 degrees over 2, that is 45 degrees. So actually, this is, let me say again, x is equals to 45 degrees in its size. Likewise, this is also, let me say angle s, let me say angle x is equals to 45 degrees in its size. In the next step, we will do a construction, that is to say from point O, that is the center of this quarter circle, we will draw perpendicular on AB. Again, from point O, we will draw perpendicular on AB. So actually, this angle equals to 90 degrees in size. This angle also equals to 90 degrees in size according to our construction. We will define the touching point of the perpendicular from point O and side AB. This point is point M. By doing this construction, we created the right triangle AMO. This right triangle AMO, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle AMO? 45 degrees plus 90 degrees is 135 degrees. So 135 degrees plus the size of this third missing angle, so that it must be equal to 180 degrees, and therefore this third missing angle must be equal to 45 degrees in size. We also have the rule that says that in front of equal angles in the triangle, there are equal sides. So if you focus on the right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other in their lengths. That is to say, side AM equals to side AMO according to the rule that I mentioned. So write it down, in the right triangle AMO, side AM equals to side OM, according to the rule that I mentioned. Again, in the right triangle AMO, side AM equals to side OM. We define the length of this line segment QM as x. AM in total equals to AQ, that is 4, plus QM, that is x. So AM in total equals to x plus 4 units in its length. So we can write down here that AM equals to x plus 4 units in its length. And from this equation, x plus 4 equals to AM equals to OM, we derive that OM must be also equal to x plus 4 units in its length. Okay? So this is the missing side OM, is equal to x plus 4 units in its length. So actually we found out that the right triangle AOM is also an associated triangle, while OM equals to AM equals to x plus 4. So in the next step, we will implement the Pythagoras theorem on this right and associated triangle, triangle AMO. Here by PT is the abbreviation for Pythagoras theorem. In this right triangle AMO, according to the Pythagoras theorem, AO squared, that is the square of the hypotenuse, equals to OM squared plus AM squared. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in the right triangle AO, it means that AO squared, that is the square of the hypotenuse, equals to OM squared plus AM squared. Actually, AO equals to R, it is the radius of the circle, of the quarter circle. If AO equals to R, then it means that AO squared equals to R squared. And R squared equals to OM squared. OM squared equals to x plus 4, and OM equals to x plus 4, therefore OM squared equals to x plus 4 squared. And AM squared also equals to x plus 4 squared. So in total, we found out that R squared equals to x plus 4 squared plus x plus 4 squared. So R squared equals to x plus 4 squared plus x plus 4 squared is 2 times x plus 4 squared. Here we take a root out of this equation, and so you get that the radius R of this quarter circle is equal to square root of 2 and times square root of x plus 4 squared. The square root of x plus 4 squared equals to x plus 4 because of the fact that the root cancels the square and we left only with x plus 4. So in total, the radius R of the quarter circle equals to the square root of 2 times x plus 4 square units in its length. This is the hypotenuse AO, this is equals to the radius of this quarter circle, and in total it is equals to the square root of 2 times x plus 4 units in its length. So I did now, the radius AO equals to 1, is equals to the square root of 2 times x plus 4 units in its length. In the next step, we will do another construction. That is to say, we draw perpendicular on this short line segment PQ at point P. Again, we draw perpendicular on this short line segment PQ at point P. So, this angle equals to 90 degrees according to our construction. And we will extend line segment OM by side line until it touches the perpendicular from point P. we define the touching point of the extended right side OM with the perpendicular from point P. This point is point N. It is given us the question that AB is a straight line. So if we focus on the upper side of the straight line AB, it's point Q. Here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have is the upper side of the straight line AB at point Q. We have this angle that is the right angle plus this missing angle. The total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. The perpendicular OM, it is absolutely a straight line. When you extend a straight line by straight line, the result ON must be also a straight line. So ON is a straight line. If you focus on the lower side of the straight line ON, it's point M. Here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the lower side of the straight line OM at point M? We have this angle that is the right angle plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. So in quadrilateral NMQP we have 1, 2, 3 angles. This angle equals to 90 degrees according to rule construction. Those two angles are both equal to 90 degrees according to rule 3. So in total in quadrilateral NMQP we have 3 right angles. The sum of 3 right angles is of course 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. So I write it down. This is quadrilateral NMPQ. In quadrilateral NMPQ, the sum of the angles must be equal to 360 degrees. That is to say 270 degrees plus the size of this fourth missing angle, the circular angle P and M. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that I mentioned. The sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation. And when we get that the missing angle P and M is equal to 360 degrees minus 270 degrees is 90 degrees. So this is the missing angle P and M, this is the right angle. So in total, we found out that the quadrilateral NMQP we have 4 right angles. And therefore we can relate to this quadrilateral PNMQ as a rectangle. So quadrilateral NMQP is a rectangle, because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NMQP, side QM must be equal to the opposite side PN, but QM is x, therefore the opposite side PN must be also equal to x units in its length. Likewise, according to the sum rule, in the sum rectangle NMQP, side PQ must be equal to the opposite side NM, but PQ is 3, therefore the opposite side NM must be also equal to 3 units in its length. In the next step, we will join points O and P together by straight line. What is the definition of line segment OP? Line segment OP starts from point O, that is the center of this quarter circle, and then at point P, that is the point of the quarter circle itself. So this is exactly the division of radius. So OP is the radius of this circle. This is equals to the square root of 2 times x plus 4 units in itself. So the next step, we will implement the Pythagoras theorem on this right green triangle P and O. Here by PT is evaluation for Pythagoras theorem. So in this general triangle P and O, according to the Pythagoras theorem, PO squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. Repeat again, in this general triangle P and O, according to the Pythagoras theorem, the following equation is true. PO squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. The hypotenuse PO equals to the square root of 2 times x plus 4. Therefore, PO squared equals to the square root of 2 times x plus 4 squared. And it equals to Pn squared. Pn is x, therefore Pn squared is x squared plus NO squared. NO in total equals to x plus 4 plus 3. X plus 4 plus 3 is x plus 7. So NO equals to x plus 7, and therefore NO squared equals to x plus 7 squared. So in total, we actually found out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. We will open the brackets on both sides of this equation, and we get that square root of 2 squared is 2 times x plus 4 squared equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, times 2 times plus 2 times x times 7, that is 14x. So in total, we should find out that 2 times 4 squared equals to x squared plus 49 plus 14x. So we have here 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. And it is equals to x squared plus x squared is 2x squared plus 49 plus 14x. Here we will open the brackets on this side of this equation, and finally get that 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times 8x is 16x, and it is equals to 2 times x squared plus 49 plus 14x. So here we subtract 14x from this equation, and we get that in this side of the equation we have 2x squared plus 32, 16x minus 14x is 2x, and it equals to 2x squared plus 49, 14x minus 14x is 0. So in total, we should find out that 2x squared plus 32 plus 2x equals to 2x squared plus 49. Here we have 2x squared on both sides of this equation, so 2x squared will get cancelled. So after we cancel 2x squared, on this side of the equation we left only with 32 plus 2x equals to 49. So here we will subtract 32 from this equation. And finally get 32 minus 32 is 0. So in this side of the equation we have to leave 2x equals to 42. 49 over 32 is 17. So in total we should find out that 2x equals to 17. Here we divide this equation by 2 and finally get that x equals to 17 halves. So if we found out that this is line segment PN is equals to x and it equals to 17 halves. Likewise, this is line segment QM, this also equals to x and x equals to 17 halves units in its length. Our test is to find out the area of this quarter circle A or B. So what is the area of this quarter circle A or B? And again, our test will find out the area of quarter circle A or B. Actually, the area of any quarter circle equals to pi times the radius of the circle squared over 4. Why? Because of the fact that a quarter circle is 1/4 of a circle. So if the radius of the quarter of a circle is pi times the radius of the circle squared, then the radius of the quarter circle must be equal to pi over the radius of the circle squared over 4. So it is pi over 4 times the radius of the circle squared. The radius of the circle squared equals the radius of this quarter circle, that's actually, of course, the radius of the circle is square root of 2 times x plus 4. Repeat again, the radius of this quarter circle equals to the square root of 2 times x plus 4, and therefore the radius square must be equal to the square root of 2 times x plus 4 square. So we have here pi over 4 times this expression. So we open the brackets of this expression and get that square root of 2 square is 2 times x plus 4 square. Here we have 2 over 4 is 1/2, so in total this expression equals to pi over 2 times x plus 4 square. We already found out that x equals to 17 halves, so we can substitute x by 17 halves and get that the quarter circle in total equals to pi over 2 times x plus 4 square. X is 17 halves plus 4 square. So the area of the quarter circle equals to pi over 2 times 17 halves plus 4. So here we will multiply 4 by 2 and then we divide it by 2 in order to come factor with this number. So 4 times 2 is 8 over 2. So we multiply 4 by 2 and then we divide it by 2, so we change nothing. Square. So total the area of the quarter circle A or B equals to pi over 2 times 17 plus 8 over 2 squared. So it is equals to pi over 2. Inside the brackets we have 17 plus 8, that is 25 over 2 square. So it is pi over 2 and 25 over 2 square equals to 25 squared, that is 625 over 2 squared, that is 4. So total the area of the quarter circle will be equals to, in the numerator of this expression we have 625 pi over 2 times 4, that is 8. 625 pi over 8 is equal to 245.437 square units in size. Okay, again, I should find out that the area that we are looking for this question. That is the area of this quarter circle A or B. In total, it is equal to either 625 pi over 8 square units in size, or in terms of numbers, the area of this quarter circle A or B equals to 245.437 square units in size. So we finished to answer the second question. In the next step, I will summarize the lecture. That is to say, I will repeat on the solution of the first question, and then we repeat on the solution of this second question. Our task in the first question was to find out the length of this line segment AQ is equal to x. We have to find out the value of x. We found out the value of x. So in the drawing, we have semicircle APCB. This is line segment QC. It is equal to 6 units in its length. This is chord CB. This is equal to 5 units in its length. This is angle PQC, that is a right angle. In addition, we know that arc PA equals to arc CB in its length. Again, our task is to find out the length of this short line segment AQ that is equal to x. We have to find out the value of x. So, we have here, this is peripheral ACB. Peripheral ACB subtend on chord AB, that is the diameter of this semicircle, and according to rule 7, any peripheral that subtend on the diameter of the semicircle or a circle must be equal to 90 degrees in size. Therefore, this is peripheral ACB, that is equal to 90 degrees in size according to rule 7, because it subtend on the diameter AB of this semicircle. Okay, so, in addition, we know that this is arc PA, this is equal to arc CB in its length. The corresponding chord of arc PA is chord PA, and the corresponding chord of arc CB is chord CB. And according to rule 56, if two arcs in the circle or semicircle are equal to each other in their lengths, then their corresponding chords must be also equal to each other in their lengths. And because of the fact that arc PA equals to arc CB in its length, therefore their corresponding chords must be also equal to each other in their lengths. That is to say, chord PA equals to chord CB in its length. If it again, because of the fact that arc PA equals to arc CB, according to rule 56, because again, chord PA equals to chord CB in its length, and therefore, according to rule 56, their corresponding chords Again, arc PA equals to arc CB in its length, according in the question. So, according to rule 56, their corresponding chords must be also equal to each other, their lengths. That is to say, chord PA equals to chord CB in its length. Okay, again, according to what is given as the equation, RKP equals to RCB in its length. And according to rule 56, the corresponding chords of those two arcs must be also equal to each other and their lengths. That is to say, RKP must be equal to RCB in its length according to rule 56. But it is given us in the question that chord CB equals to 5 units in its length. So we can write it that chord CB equals to 5, and for this equation AP equals to CB equals to 5, we derive that chord AP must be also equal to 5 units in its length. So here, this is chord PA, this is also equals to 5 units in its length. In the next step, we join points P and C together by straight line. By joining points P and C, we get the triangle PCA. This is triangle PCA that subtends on chord PA that is equal to 5 units in its length. Likewise, we have another triangle PCA, PCB. This triangle CAB that subtends on chord CB that is also equal to 5 units in its length. And because of the fact that those two triangles subtend on equal chords, that is equal to 5 units, they must be equal to each other in their sizes. So if the size of this triangle PCA equals to alpha, then the size of this triangle CAB must be also equal to alpha because they are equal to each other according to rule 56. Okay, again, according to rule 56, because of the fact that those two triangles subtend on equal chords, must be also equal to each other in their sizes. This is to say, triangle PCA must be equal to triangle CAB in its size according to rule 56. According to rule 57. So if we define the size of this triangle PCA as alpha, then the size of this triangle CAB must be also equal to alpha because of the fact that they are equal to each other according to rule 57. So in this green triangle PCQ, this angle equals to alpha, this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in this right lower triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha according to the sum that said that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that the right triangle PQC is similar to the right lower triangle ABC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So if you found out that all the figures of this right triangle PQC are corresponding equal to all the figures of this right triangle ABC, and therefore those two right triangles are similar to each other according to angle similarity rule. So if again we should find out that the right triangle PQC is similar, this is the sign of similar, to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC over side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC over side AC of this right lower triangle ABC. Again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of the green triangle or side CB of the right lower triangle ABC equals to side QC of the green triangle or side AC of the right lower triangle ABC. PQ is the missing side, so we leave it as it is. CB is 5, QC is 6, AC in total equals to AQ, that is X, plus QC, that is 6. So in total, AC equals to X plus 6 units in its length. And again, AC equals to X plus 6 units in its length. So in total, we should find out that PQ over 5 equals to 6 over X plus 6. Here we multiply this equation by 5 and finally found out that the missing side PQ equals to 5 times 6, that is 30 over X plus 6 units in its length. So this is the missing side PQ. That is equals to 30 over X plus 6 units in its length. It has given us the question that AC is a straight line. So if we focus on the upper side of the straight line AC at point Q, here the sum of the areas must be equal to 180 degrees according to Rule 3. Rule 3 said that the sum of the areas from one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AC at point Q? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to Rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, triangle APQ is a right angle. In the next step, we play the Pythagoras theorem on this right angle, triangle APQ. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this triangle APQ, AP squared, this is the square of the hypotenuse, equals to PQ squared plus QA squared. Because again, in this right angle APQ, according to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. AP is 5, therefore P squared is 5 squared, that is 25, and it equals to PQ squared. PQ is 30 over X plus 6, therefore PQ squared equals to 30, is equals to 30 over X plus 6 squared plus QA squared. QA is X, therefore QA squared is X squared. So in total we should find out that 25 equals to 30 over X plus 6 squared plus X squared. So 25 equals to, what is the value of this expression, 30 over X plus 6 squared? 30 over X plus 6 squared equals to 30 squared, that is 900, or X plus 6 squared, plus X squared. So 25 equals to 900 over X plus 6 squared plus X squared. Here we multiply the X squared by X plus 6 squared, then we divide it by X plus 6 squared in order to have a common factor with this expression, with this number. So we have X squared times X plus 6 squared over X plus 6 squared. So multiply it by X plus 6 squared, then we divide it by X plus 6 squared, so we change nothing. It is allowable to multiply anything by 1. So in total we should find out that 25 equals to 900 plus X squared times X plus 6 squared over X plus 6 squared. So here we multiply this equation by X plus 6 squared, and finally found out that we have 25 times X plus 6 squared, and here we left only 900 plus X squared times X plus 6 squared. What X plus 6 squared, we get cancelled. So in total we should find out that 25 times X plus 6 squared equals to 900 plus X squared times X plus 6 squared. So we have 25 times X plus 6 squared. X plus 6 squared equals to X squared plus 6 squared, that is 36, plus 2 times X times 6, that is 12X, and it equals to 900 plus X squared times X plus 6 squared. X plus 6 squared equals to X squared plus 6 squared, that is 36, plus 2 times X times 6, plus 2 times X times 6, that is 12X. So here we open the brackets on both sides of this equation. So in this side of the equation we have 25x times x squared, that is 25x squared. 25 times 36 is 900, and 25 times 12x is 300x. In the other side of the equation we have 900, and here we open the brackets of this expression. X squared times x squared is x to the power of 4, plus x squared times 36 is 36x squared, and we have x squared plus 12x is equal to 12x cubed. So here we have 900 on both sides of this equation, so 900 will get cancelled. After I cancel 900 in the side of the equation, we left only with 25x squared plus 300x, while on the other side of the equation, we left only with x to the power of 4 plus 12x cubed plus 300 plus 36 36x squared. So here we subtracted 25x squared from this equation, so here we're left only with 300x, while on the other side of this equation we're left with x to the power of 4 plus 12x cubed, and 36x squared minus 25x squared equals to 11x squared. So total we should find out that 300x equals to x to the power of 4 plus 12x cubed plus 11x squared. Here we subtracted 300x from this equation, so in this side of the equation we left with nothing, that is to say 0, while in the other side of the equation we have x to the power of 4 plus 12x cubed plus 11x squared minus 300x. So because we subtract 300x from this equation. So in total we should find out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. And again, we should find out that x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. So here we took x as a common factor from those four expressions. So inside the brackets we left only with x cubed plus 12x squared plus 11x minus 300 equals to 0. This equation has two solutions. The first solution for this equation is x equals to 0. If x equals to 0, then 0 times anything is 0. We get that the right side of the equation equals to the left side of the equation. 0 equals to 0. The second solution for this equation is the expression inside the brackets is equals to 0. So 0 times x is 0. So we get that 0 equals to 0. So the first solution for x is the first solution to this equation is that x equals to 0, while the other solution to this equation is that x cubed plus 12x squared plus 11x minus 300 equals to 0. But x can never be equal to 0. Why? Because of the fact that x is the length of this line 17 so x is a length, it must be a positive number, and therefore can never be equal to 0, that is definitely not a positive number. So we cancel the solution for x because x can never be equal to 0. Must be a positive number. The other possibility for the solution of this equation is the expression inside the brackets of this equation equals to 0. That is to say x cubed plus 12x squared plus 11x minus 300 equals to 0. First of all, we checked if this equation is true for x equals to 3. So if x equals to 3, it means that we can substitute x by 3. X cubed is 3 cubed. 3 cubed is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, therefore x squared is 3 squared, that is 9. So it is 9 times 12, that is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, minus 300 equals to 0. Here, 108 plus 33 plus 27 in total is equals to 168 minus 300. So 168 minus 300 is definitely not equal to 0. So x equals to 3 is not the solution of this equation, because those two sides of the equation are not equal to each other. In the next step, we checked if x equals to 4 is the solution for this equation. That is to say, we substitute x by 4. So x cubed is 4 cubed, that is 4 times 4 times 4, that is 64, plus 12x squared. X is 4, therefore x squared is 4 squared, that is 16, so in total this expression equals to 12 times 16, that is 192, plus 11x. X is 4, so 11x is 11 times 4, that is 44, minus 300, equals to 0. 64 plus 44 is 108, 108 plus 192 is 300, 300 minus 300 equals to 0. So x equals to 4 is the solution of this equation, and therefore we can express this expression in a different way. Actually, this expression in total equals to, again, this expression is x cubed plus 12x squared plus 11x minus 300 equals to 0. This expression in total equals to x minus 4 times x squared plus 16x plus 75. Actually, if we open the brackets of this expression, we get that this expression equals to x cubed plus 12x squared plus 11x minus 300. You can check it by yourself. Those two expressions are identical, and this expression equals to 0. So we can substitute this expression by x minus 4 times x squared plus 16 x minus 4 times x squared plus 16x plus 75 equals to 0, because those two expressions are identical. So we substitute this expression by this expression, and this expression equals to 0. This is to say this identical expression must be also equal to 0. Now it is very easy to solve this equation. We have two solutions that are possible for this equation. According to the first solution, x minus 4 equals to 0. So if x minus 4 equals to 0, it means that 0 times anything equals to 0, and we get that 0 equals to 0. So the first solution for this equation is x minus 4 equals to 0. We have another solution to this equation. If the expression inside this bracket equals to 0, then 0 times x minus 4 equals to 0, and we get that 0 equals to 0. So the second solution for this equation is x squared plus 16x plus 75 equals to 0. According to the first solution to this equation, x minus 4 equals to 0. We added 4 to this equation and finally we found out that x equals to 4. So the first solution to this equation is that the length of right side equals to x is equal to 4 units in its length. Now we check if the other solution for x, if the other solution to this equation is a correct solution. So that is to say, we must verify that x squared plus 16x plus 75 indeed could be equal to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. The expression inside the root is the determinant of this quadratic equation. So the determinant of this quadratic equation is b squared minus 4 times ac. And in order that this quadratic equation will have any solution at all, the determinant of this quadratic equation must not be a negative number. That is to say, b squared minus 4 times a times c must not be a negative number. Otherwise, it will not have any solution at all. If the determinant of a quadratic equation is a negative number, it has no solution at all. So now a specific quadratic equation, that is to say x squared plus 16x plus 75 equals to 0. Now a specific quadratic equation, x squared plus 16x plus 75 equals to 0. The coefficient A equals to 1, the coefficient B equals to 16, and the coefficient C equals to 75. The determinant of any quadratic equation equals to b squared minus 4 times ac. So we must verify that the determinant of our specific quadratic equation is not equal to a negative number. So what is the determinant of this quadratic equation? It is b squared minus 4 times ac. B is 16, therefore b squared is 16 squared, that is 256, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is 75, so minus 4 times 75 is minus 300. So the determinant of our specific quadratic equation is equal to 256 minus 300. This is definitely a negative number. And because of the fact that the determinant of our quadratic equation is a negative number, it means it is no solution at all. Okay? So this quadratic equation, x squared plus 16x plus 75 equals to 0 is no solution at all. This is to say, you cannot find any real number that solves this equation. You cannot find any real number in such a way that the left side of the equation equals to the right side of the equation. So this quadratic equation has no solution at all. And therefore, we can cancel this solution, this incorrect solution. Another way to find out that this quadratic equation has no solution at all is by substituting 75 by 16 plus 11. So this expression equals to x squared plus 16x, and 75 is 64 plus 11. Okay, and we get that x squared plus 16x plus 64 plus 11 equals to 0. X squared plus 16x plus 64 is x minus 8 squared plus 11 equals to 0. If you subtract 11 from the equation, we get that x minus 8 squared equals to minus 11. X minus 8 squared is definitely a positive number, and it can never be equal to minus 11, that is a negative number. So this is the second way to find out that x squared plus 16x plus 75 has no solution at all, because a negative number can never be equal to a positive number. So I presented two ways to find out that x squared plus 16x plus 75 is not the solution to this equation. So the only solution to this equation is that x is equals to 4. So if we found out that the length of this line segment AQ is equals to x is equal to 4 units in its length. So we finished with the first question. In the next step, I repeat on the solution of the second question. In the second question, our task was to find out the area of this quarter circle AOB. So in the drawing, we have quarter circle AOB. This is a right angle, it is true in any quarter circle. Line segment PQ equals to 4 units in its length, line segment AQ equals to 4 units in its length, and this is angle PQ8, this is a right angle. Again, our task is to find out the area of this quarter circle AOB. First of all, OA equals to OB, they are both the area of this quarter circle, and therefore they are equal to each other. So if we find the radius AO as R, then the radius OB must be also equal to R. We also have the rule that says that in any triangle, in front of equal sides, we have equal angles. So in this right triangle AOB, in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as x, then the size of this angle must be also equal to x, because they are equal to each other according to the rule that I mentioned. And we also have the rule that says that the sum of the angles in a triangle is equal to 180 degrees. So in the right triangle ABO, x plus x is 2x plus 90 degrees, in total it must be equal to 180 degrees. And again, we should find out that this right triangle ABO, the sum of the angles must be equal to 180 degrees. That is to say 2x plus 10 degrees equals to 180 degrees. Here we subtract the 90 degrees from this equation. If we found that the 2x equals to 180 degrees minus 90 degrees is 90 degrees. So 2x equals to 90 degrees. Here we divide this equation by 2, and if we found out the missing angle x equals to 90 degrees over 2, that is 45 degrees. So this is the missing angle x is equals to 45 degrees in size, and this is also the missing angle x is equals to 45 degrees in size. In the next step, we did the construction, that is to say, from point O, that is the center of this quarter circle, we do perpendicular on AB. Again, from point O, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB. This point is point M. By doing this construction, we can do the right triangle AMO. And we have the rule that set in front, that set in a triangle in front of equal angles, we have equal sides. So in the right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other and the rest. So in the right triangle AMO, AM equals to MO according to the rule that I mentioned. And again, in the right triangle AMO, AM equals to OM. We find the length of this line segment QM is X, AQ equals to 4. So in total, AM equals to 4 plus X. So we can write here that AM equals to X plus 4. And for this equation, X plus 4 equals to AM equals to OM, we derive that OM must be also equal to X plus 4 units in its length. This is the missing side OM. This is also equals to X plus 4 units in its length. So the right triangle AM is also an associated triangle. So OM equals to MA. So in the next step, we implement the Pythagoras theorem on this right triangle AMO. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in this right triangle AMO, AO squared, that is the square of the hypotenuse, equals to OM squared plus AM squared. And again, in the right triangle AOM or AMO, AO squared, that is the square of the hypotenuse, equals to OM squared plus AM squared. AO, the hypotenuse AO is also the radius of this quarter circle, is equals to R. Substitute AO by R. Therefore, AO squared equals to R squared. If AO is R, then AO squared equals to R squared. And so R squared equals to OM squared. OM is X plus 4, therefore OM squared is X plus 4 squared, plus AM squared. AM is also X plus 4, therefore AM squared is X plus 4 squared. So in total, we actually found out that R squared, that is the square of the hypotenuse, equals to X plus 4 squared plus X plus 4 squared. X plus 4 squared plus X plus 4 squared is 2 times X plus 4 squared. So in total, we found out that R squared equals to 2 times X plus 4 squared. Here we took out of the equation and finally found out that the radius R of the quarter circle equals to the square root of 2, and the square root of X plus 4 squared equals to X plus 4, because the root cancels the square, and we're left only with X plus 4. So the radius of the quarter circle R equals to the square root of 2 times X plus 4 units in its length. This is the radius R of this quarter circle. This is equal to the square root of 2 times X plus 4 units in its length. In the next step, we did another construction, that is to say, we do perpendicular on this short line segment PQ at point P. Again, we do perpendicular on this short line segment PQ at point P. So this angle equals to 90 degrees according to our construction. So we have here, this gives us the equation that AB is a straight line. So if you focus on the upper side of this straight line AB at point Q, the sum of the angles must be equal to 180 degrees according to all three. All three said that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, OM is a perpendicular, it is absolute a straight line. When you extend a straight line by a straight line, the result ON must be also a straight line. So ON is a straight line. So if you focus on the lower side of the straight line ON at point M, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the lower side of the straight line OM at point M? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees in its size. So in total, in quadrilateral NMQP, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction, and those two other angles also equal to 90 degrees in their sizes according to all three. So in total, in the right triangle, in quadrilateral NMQP, we have 3 right angles. The sum of 3 right angles is of course 270 degrees. So 270 degrees plus the size of this 4 3 second in total must be equal to 360 degrees. According to the rule that said that the sum of the angles in a quadrilateral is equal to 360 degrees. So the missing angle is P and M. So in quadrilateral NMQP, in quadrilateral NMQP or PQ, the sum of the angles must be equal to 360 degrees. That is to say 270 degrees plus the size of the 4th missing angle that is actually angle P and M in total must be equal to 360 degrees. Here we subtracted 270 degrees from this equation and find out that the missing angle P and M is equal to 360 degrees plus 270 degrees, that is 90 degrees. So this is the missing angle P and M, this is equal to 90 degrees in size. So in total, in quadrilateral NMQP, we have 4 angles, and therefore we can relate to this quadrilateral PNMQ as a rectangle because it has 4 rectangles. But you also know that the opposite sides of a rectangle are equal to each other. So in rectangle PNMQP, side QM must be equal to the opposite side PN. But QM is x, therefore the opposite side PN must be also equal to x units in its length. Likewise, according to the sum rule, in the same rectangle PNMQ, side PQ must be equal to the opposite side NM. But PQ is 3, therefore the opposite side NM must be also equal to 3 units in its length. In the next step, we join points on P together by straight line. So, what is the definition of line segment OP? Line segment OP starts from point O, that is the center of the quarter circle, and that's at point P, that is the point of the quarter circle itself. So, this is exactly the definition of a radius. That is to say, OP is the radius of this quarter circle, that equals to the square root of 2 times x plus 4 units in its length. In the next step, we implement the Pythagoras theorem on this right triangle P and O. On this right triangle P and O, according to the Pythagoras theorem, OP squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. But again, this again right triangle P and O, according to the Pythagoras theorem, PO squared, that is the square of the hypotenuse, equals to Pn squared plus ON squared. The hypotenuse PO is the radius of this quarter circle. This is equals to the square root of 2 times x plus 4, and therefore PO squared must be equal to the square root of 2 plus x plus 4 squared, and it is equals to Pn squared. Pn is x, therefore Pn squared is x squared plus NO squared. NO in total equals to x plus 4 plus 3, that is x plus 7. So NO equals to x plus 7, and therefore NO squared must be equal to x plus 7 squared. So in total, if you found out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. So here, open the brackets on both sides of this equation and find out that square root of 2 squared is 2 times x plus 4 squared equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x plus 2 times x times 7, that is 14x. Here we have 2 times x plus 4 squared, so it is 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. So in this side of the equation, we have 2 times x squared plus 16 plus 8 squared plus 8x, and it is equals to, here we have x squared plus x squared is 2x squared plus 49 plus 14x. Here we open the brackets of this side of this equation and find out that 2 times x squared is 2x squared plus 2 times 16 is 32 plus 2 times 8x is 16x equals to 2x squared plus 49 plus 14x. So here we have subtracted 14x from this equation. So in this side of the equation we have 2x squared plus 32, and 16x plus 14x is 2x, and it equals to 2x squared plus 49, and here 14x plus 14x is 0. So in total, we actually found out that 2x squared plus 32 plus 2x equals to 2x squared plus 49. Here we have 2x squared on both sides of this equation, so 2x squared will get cancelled. So in this side of the equation, we have only 32 plus 2x equals to 49. So here we subtracted 32 from this equation. In total, we found out that 2x equals to 49 minus 42 is 17. So 2x equals to 17. Here we divided this equation by 2 and we found out that x equals to 17 half units in its length. Actually, this is 97 p.m. This is equals to x, and x equals to 17 ops. Likewise, this is 97 qm. This is also equals to x, and x equals to 17 ops units in its length. Our test is to find out the area of this quarter circle, A or B. And again, our test is to find out the area of quarter circle, A or B. The area of any quarter circle must be equal to the area of the circle over 4, because a quarter circle is a quarter of a circle. Therefore, we have to divide the area of the circle by 4. So again, the area of any quarter circle must be equal to pi times the radius of the circle squared, that is the area of the circle over 4. So it is pi over 4 times the radius of the circle squared. The radius of the quarter circle is square root of 2 times x plus 4, and the radius square must be equal to the square root of 2 times x plus 4 squared. So we have here pi over 4, and we open the brackets of this expression. Square root of 2 squared is 2 times x plus 4 squared. We already found out that x equals to 17 halves, so we can substitute x by 17 halves, so we did it. And we can find out that in total the area of quarter circle will be equals to pi over 4 times 2. 2 over 4 is 1 half. So this expression in total equals to pi over 2 times x plus 4 squared. Here x equals to 17 halves, so we substitute x by 17 halves. So in total, the area of the quarter circle A or B equals to pi over 2. And we have x is 17 halves plus 4. Here we multiply plus 4 squared, this square. Here we multiply 4 by 2, and then we divide it by 2 in order to become a factor with this number. So we have pi over 2 times 17 over 2, and 4 times 2 is 8, and 8 over, so we multiply 4 by 2, and then we divide it by 2, so we change nothing. So in total, the area of quarter circle A or B equals to pi over 2 times 17 plus 8 over 2 squared. 17 plus 8 is 25, so in total, the area of quarter circle A or B must be equal to pi over 2 times 25 over 2 squared. So it is pi over 2 times 25 over 2 squared. 25 over 2 squared, 25 over 2 squared equals to 25 squared, that is 625 over 2 squared, that is 4. 2 times 4 is 8, so in total the root of this expression equals to 625 over 8 square units inside. So actually found out that the area that we are looking for this question, that the area of this quarter circle A or B equals to either 625 pi over 8 square units inside, so we take some numbers. The area of this quarter circle A or B equals to 245.437 square units in size. Okay, thank you very much.